Hello, sixth grade. This is your Module 4 review. All right, question 1. Amanda is planning out her vegetable garden. She decides that her garden will be square. Below are possible sizes of the garden she will create. Complete the table by continuing the pattern. So the keywords here are square. So that means all sides are going to be the same. So in the first one, we have 1 foot, which as our notation is 1 squared equals 1 times 1 equals 1. The formula that we have is area equals length times width. Our area then is 1 foot by 1 foot. Our area is 1 foot squared, or simplified to 1 foot, and then a representation. So then 2 feet is going to be 2 squared equals 2 times 2, or 4. And if we do area equals length times width, our area is 2 feet by 2 feet. Our area is 2 squared feet squared, or our area is 4 feet squared. And then we already have the image. So then we're going to continue on with the rest of them. So 3 feet is going to be 3 squared, or 3 times 3, and that simplifies to 9. So our area is length times width. Area is 3 times 3 feet squared. Sorry, feet. Our area is 3 squared feet squared, and the area is 9 feet squared. So then as a representation of that, we would have a 3 by 3 box. And then we're going to continue on. So 4 feet is going to be 4 squared equals 4 times 4, which is equal to 16. Our area is length times width. The area here is 4 feet times 4 feet. The area is 4 squared feet squared, or our area is 16 feet squared. And then we're going to do the same thing. So I have 4 by 4, or 16. And then we're going to do the same thing with 5. So I have 5 squared equals 5 times 5, which is 25. My area equals length times width. My area is 5 feet times 5 feet. The area is 5 squared feet squared. My area is 25 feet squared. And then we will do a 5 by 5 square. So then for x, we're going to do that in a generic term because we don't know how many feet she's actually going to do. So I have x squared is equal to x times x, or again, x squared. My area in this case is length times width. My area is x feet times x feet. Area is x squared feet squared. And then to represent this, you would just make a box and put x on each side because we don't know what that value is. Amanda decides the length of her square vegetable garden will be 17 feet. She calculates the area of the garden to be 34 feet squared. Determine if Amanda's calculation is correct. Explain your reasoning. So if we are going to replace our 17 feet into this equation, we would have area equals 17 squared feet squared. If I calculate that, so we'll do this the long way. It's 1,209 if I did that correctly. So that is not 34. So 34 would be 17 times 2, which is not what we're doing. We're doing the side times the side. Oh, sorry, 289. Good thing I checked. All right, so then Amanda, she's going to create garden cubes to plant flowers. She will fill the cubes with soil and needs to know the amount of soil that will fill each garden cube. The volume of the cube is determined by the following formula. So we're using this formula, V equals S cubed, where S represents the side length. So represent the volume in cubic inches of the garden above using a numerical expression. So if our volume is S cubed and one side is 32, we're going to have V equals 32 cubed. So now we're going to evaluate the expression to determine the volume of the cube. So if our volume is 32 cubed, our volume is 32,768 inches cubed. Okay, B then, explain why 1/2 to the fourth is 1/16. So essentially what we're doing is we're doing 1/2 times 1/2 times 1/2 times 1/2, because our exponent is telling us how many times we're multiplying that base. So if we do our rules of fractions, we multiply the top and then we multiply the bottom. So the top is just going to be 1/2, 1, and then we do 2 times 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So we're trying to explain why this is happening. So we're not doing 1/2 times 4, which some people might say 1/8, because we are multiplying 1/2 4 times, we get 1/16. All right, question 4. Beth is building a patio in her backyard. She is interested in using both brick and wood for the flooring of the patio. Below is the plan that she created for the patio. All measurements are in feet. Create an expression to represent the area of the patio. So we're talking about area. So in order to find area, we have to do length times width. So our length here is this 3 and this x, and then our width is this 12. So we would have to add this piece and this piece together, and then we would have to multiply times that 12.5. Beth's husband develops another plan for the patio because he prefers the patio to be much wider than Beth's plan. So as you can see, these values are bigger. Determine the length of the brick section and the length of the wood section. Then use the dimensions to write an expression that represents the area of the entire patio. So we have 24 on the side, we have a 48x here, and we have 96. So again, to find the area, we have area equals length times width. So we have some of these values. So here we can find this 96 first. So if this is my area, so I'm going to have 96 equals 24 times the length, and then we're just going to divide both sides by 24. So our length is equal to 4. So this value would then be 4. Then we can do the same thing with the brick side. So I'm going to have 48x equals 24 times my length. We have a length here of 12 and 3, so we can figure out what this is and compare it to this. So 12.5 times 3 is 37.5. So we have a slightly larger area here. So if we divide both sides by 24 here, and get 2x equals L. So whatever this x is, I'm just going to multiply it times 2. All right. So then the landscaper comes in and he's like, no, we're going to change this again. So he suggests a patio that has the same measure of the wood as the brick. So even though the two sides, we have the brick on the left and the brick on the right, it's the same length as this area. So we're going to express the perimeter of the patio in terms of x, first using addition, then using multiplication. So in order to find the perimeter, we have to add all these sides together. So I have an x here, an x here, an x here, an x up there, an x, an x, an x, and a 2x. So then I can simplify that to become 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to equal 10x. So here I have my addition, here I have the multiplication. Use substitution to determine if your expressions are equivalent. So if we do some sort of multiplication up here, I could do 2, 3, and a 4. So I can have 4x plus, and then I have 2 of those. Sorry, let's do it this way. I have a 4x here and a 4x here, and then an x here. So I can add one side and then multiply it times 2. So then if I simplify that, I have 8x plus 2x, which again equals 10x. So yes, no matter what value I put in, because I got 10x on both sides, they are going to be equivalent. All right, number 6. Carly and Dennis have similar problems and find the same answer. Each determines that the solution of the problem is 24. Carly's expression is 14 plus 42 divided by 7 plus 4 squared. Dennis is 14 plus the quantity 42 divided by 7 plus 4 squared. So we have to evaluate each expression to determine if Carly and Dennis are correct. So what we have to do is we have to do order of operations. So I'm going to do Carly first. So she has 14 plus 42 divided by 7 plus 4 squared. 14 plus 42 is 56 divided by 7 plus 4 squared. So we're doing our order of operations. So 56 divided by 7 plus 16. 56 divided by 7 is 8. 8 plus 16 is 24. So then Dennis, again, we're going to do that same order of operations. I have 14 plus 42 divided by 7 plus 4 squared. My parentheses are first, so 42 divided by 7 is 6 plus 4 squared. 14 plus 6 plus 16. If I add those together, I get 36. So no, they should not get the same expression. Why would each find the solution of 24? What mistakes were made, if any? So if you're not paying attention to that order of operations, if you're just working left to right, then they would get the same answer. So Dennis was not following the order of operations. All right, problem 7. Edgar gave Frank this expression to evaluate. 14 times the quantity 8 plus 12. Frank said that to evaluate the expression was simple, just to multiply the factors 14 and 20. And then Edgar told Frank that he was wrong. Edgar solved it by finding the product of 14 and 8 and then adding that to the product of 14 and 12. So if we write this out, so we have 14 times 8 plus 12. Frank said you multiply the factors 14 times 20, and then you get your answer. Edgar says, okay, so we have the same one, 8 plus 12. You do 14 times 8 plus 14 times 12. So if we do 14 times 8, that gives us 112. And 14 times 12 gives us 168. For a total of 280. If we do 14 times 20, that also gives us 280. So, they want to know who was right. So, who was right? So, order of operations tells us to do parentheses, exponents, multiplication, division, addition, subtraction. So the parentheses should have been done first. However, we can sometimes multiply. So Frank is correct. Because he used the order of operations. But Edgar wasn't completely wrong to distribute. All right, Gertrude is deciding which cell phone plan is the best deal for her to buy. Supercell charges a monthly fee of $10 and also charges 15 cents per call. She makes a note that the equation is M equals 0.15C plus 10, where M is the monthly charge in dollars and C is the number of calls placed. Global Cellular has a plan with no monthly fee but charges 25 cents per call. She makes a note that the equation is M equals 0.25C, where M is the monthly charge in dollars and C is the number of calls placed. Both companies offer unlimited text messages. Make a table for both companies showing the cost of service, M, for making 0 to 200 calls per month. Use multiples of 20. So our number of calls are going to go 20, 40, 60, 80, 100. Let's make that 0. All right, so all I'm going to do is I'm going to replace this value into C. So the number of calls C gets replaced with this value. So nope, that one's dead. One second while I grab a calculator. All right, so here we are. So I'm going to replace this C with this value. So I'm going to do 0.15 times 20 plus 10. So that gives me a total of $13. And then I'm going to continue along all the way down. So 0.15 times 40 plus 10 is 16. 0.15 times 60 plus 10 is 19. 0.15 times 80 plus 10 is 22. And hopefully you are beginning to see a pattern. 0.15 times 100 plus 10 is 25. So if you notice, we're increasing by 3 each time, so I'm just going to continue that pattern. Okay, then we're going to do the same thing for this side. So I'm going to do 0.25 times 20, which is $5. Nope, sorry. 40 times 0.25 is $4. Nope, that can't be right. 40 times 0.25, $10. There we go. And 60 times 0.25 is 15. 80 times 0.25 is 20. And again, I hope you are starting to see a pattern. So we are increasing by $5, so I'm just going to continue that pattern. Construct a graph for the two quantities on the same graph. Use the number of calls C as the independent variable and the monthly charge in $M as the independent. So our number of calls goes on the bottom because that's our independent, and then our total cost in dollars goes on the side. So now I'm going to use different colors to help differentiate our data. So I'm going to use purple for supercell. And blue for global cellular. So if you notice, I added 0 on the bottom. So regardless, if she chooses Supercell and she doesn't make any phone calls, she still has to pay $10. If she chooses Global Cellular and doesn't make any phone calls, she's not paying anything. So that's that monthly fee. So we will put these side by side. Okay, so I'm going to do these in increments of 10. Since there was 20. And then if we look at our data here, the highest value goes up to 50. So, and again, we have 20. So if I do 50 divided by 20, that's 2.5. So we will do these in increments of 2. It actually should be 3. But you'll be able to see the graph. Okay, so my first data point for Supercell is 010. My second data point is 2013. My third one is 4016. Next is 8019. Nope, which one? Sorry, skipping. 6019. And then 8022. And you should start to be able to see that line develop. Let's see, which one? 125. And I think that's good enough. So now we will connect this. 1 second. And there's the graph of the line for supercell. Next we will do global cellular. So this one we start with 0, 0. Then at 20 we have $5. 40 is 10. 60 is 15. 80 is 22. 80 is 20. 100 is 25. 120 is 30. Okay, and then we will connect those as well. So, question B then says, which cell phone plan is the best deal for Gertrude? Defend your answer with specific examples. So, your answers are going to vary. Now, if this was a test question, you would not write this. You are going to be explaining about this. So, right here is a point where the graphs intersect. So based on this information is how you would explain which one is better. So if she makes less than 100 phone calls, global cellular is going to be better. If she makes more than 100 calls, supercell is better. But you need to explain, you need to take one answer. Which cell phone is better? So based on how much you think she calls, that is going to be dependent on which one is better. So think there's typically 30 days in a month. How many phone calls does she make per day? Would be dependent on how many phone calls she makes that month, and it will depend on which one is better. All right. Hannah is saving her money to buy a new pony, which costs $600. She already has $75. She earns $50 per week working at the stables and wonders how many weeks it will take to earn enough money for her own pony. So we're going to make a table showing the week number W and total savings in dollars S for Hannah's savings. So our number of weeks are going to be 1, 2, 3. You can start with 0, 5, 6, 7, 8, 9, 10, 11, 12. So she has $75 and then she's earning $50 per week. So this first week, she's gonna have the $75 that she's already saved plus this 50. So that gives us 125. Now I'm gonna continue adding 50 because she's earning 50 per week. So 175, 225, 275, 325. Okay, so that's us filling in the chart. Show the relationship between the number of weeks and Hannah's savings using an expression. So we're using some sort of expression. So to find out the total, we're going to have 50W plus 75. So she's getting 50 per week plus that 75 that she already started with. How many weeks will Hannah have to work to earn to buy her own pony? So at week 11, she has more than enough. So she needs to work 11 weeks to save for her pony. The elevator at the local mall has a weight limit of 1,800 pounds and requires that the maximum person allowance to be no more than 9 people. Let X represent the number of people. Write an inequality to describe the maximum allowance of people allowed in the elevator. So we're talking about people in this one. So 9 people. So X needs to be less than or equal to 9. Okay, because we can't have more than 9. We can have 9, but we can't have more than 9. Okay, we're going to draw a number line to represent this. Okay, so I have a number line. I'll add one here. I have it beyond 9. So we're putting numbers somewhere around 9. We're going to put a circle on 9 because it's equal to. I'm going to circle that in. And then it's pointing to the left. So I'm going to draw a line to the left, which means that any number of these people can be in the elevator. Now we're letting W represent the amount of weight in pounds. Write an inequality to describe the maximum weight allowance in the elevator at one time. So our weight here is 1,800. So W is going to be less than or equal to 1,800. And then we're going to do the same thing. So I'm going to put a circle on 1,800, fill it in, and then it's everything less than that. So I can have 1,500 pounds, I can have 1,000 pounds, I just can't go above that 1,800. All right, Devon's football team carpools for practice every week. This week is his parents' turn to pick up team members and take them to the football field. While staying on the roads, Devon's parents always take the shortest route in order to save gas. Below is a map of their travels. Each grid line represents a street and the same distance. So Devon's father checks his mileage and notices that he drove 18 miles between his house and stop 3. Create an equation and determine the amount of miles each grid line represents. So what we're going to do, hello, yep, go ahead, is we're going to figure out how he's driving. So we would go 1 square here, 1, 2, 3, 4, 5, So this is most likely the quickest route. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 lines are equal to 18 miles. So in order to figure out how much each one is, we would divide both sides by 9. X equals 2. So it's 2 miles for each line. Use this information, determine how many miles Devin's father will travel from home to the football field, assuming he made every stop. Explain how you determine your answer. So if we continue, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's 15 grid lines from the house to the football field, and all we have to do is multiply that times 2, which gives us 30 miles. At the end of practice, Devin's father dropped off the team at each stop and went back home. How many miles did he travel altogether? So if we are going 30 miles one way and 30 miles back, so I have my 15 times my number of grid lines, and then we're multiplying that times 2. And if we know that our grid line was each 2, this ends up being 2 times 30, or 60. For a science experiment, Jackson reflects a beam off a mirror. He is measuring the angle created when the light reflects off the mirror. So if you notice that the figure is not necessarily drawn to scale, use an equation to determine the missing angle, labeled X in the diagram. So if you notice, this is a straight line. So I'm going to do 180 equals 51 plus X plus 51. If I simplify that, I have 51 plus 51, which is 102, plus X. I'm going to subtract 102 from both sides. So this is 78 equals X. So this is 78 degrees. All right, and then we have some quick definitions here. So these were in, I can't remember which page, 97, I believe. The definitions weren't there per se, but you could Google them. But there was a table. So the additive property of 0 is any number plus 0 is equal to that value. The multiplicative identity property of 1 was any number times 1 equals that number. The commutative property of addition sure I'm getting it exactly right, is A plus B equals B plus A. So you can alternate those values. The commutative property of multiplication is similar to that. So you have A times B equals B times A. And then your distributive property, if you have A times B plus C, you get A times B plus A times C. If you have any questions, please let me know. Good luck tomorrow, and remember to bring your reviews.